Hello everyone, welcome to lecture number 18 doubt solving session on static timing analysis for combinational circuits. In today's lecture we are going to solve this numerical on finding the return time and at each node, find the slack at each node of this combinational circuit and find the arrival time at each node. Arrival time at node A, B, C, D, E, F is 0, 0. So 0, 0 is not the denominator, it is the rise time and the fall time. Here, similarly, this will be the rise and this will be the fall time. All right. And these are the delays associated with the gate 4 by 3. This is the rise delay, fall delay. 3 by 5 is the rise delay, fall delay for this NOR gate. Then there are certain non-inverting gates like AND gate, OR gate, and an buffer. So there are around 4 inverting gates: NAND, NOR, another NAND, and another NOR. So two NOR and two NAND gates are the inverting gates, and the AND gate, OR gate, and a buffer is a non-inverting gates. So let us revise the formula first. So the output rise arrival time is equal to maximum of input fall arrival time plus the rise delay. Output fall arrival time is equal to maximum of input rise arrival time, because it's an inverting gate, plus T fall. This is the fall delay. Input rise arrival time is equal to minimum of output fall arrival time minus fall delay. Input fall arrival time is equal to minimum of output rise arrival time minus T rise delay. For non-inverting gates, output rise arrival time is max of input rise arrival time plus rise delay. Output fall arrival time is equal to max of input fall arrival time plus fall delay. Input rise arrival time is equal to minimum of output rise arrival time minus rise delay. And input fall arrival time, this would be fall. So input fall arrival time is equal to minimum of output fall arrival time minus fall delay. So with the help of these 8 formulas for inverting and non-inverting gates, we will find the return time, arrival time, and the slack at each node. So let's begin with node number A. So for node A, arrival time is given as 0, 0. That will be rise time and fall time. Remember, it's not a division. So we can write for node A, arrival time at node A is 0, 0. All right. And next we have to calculate the at node B. First, let us find out the arrival time at all the nodes. So for node A, it's given as 0, 0. For node B, it's also given as around arrival time is, let me bring it over here. Yeah, I think this is fine. Yeah. So for node B, the arrival time at node B is 0, 0, and at node C, arrival time is 0, 0. The rise time and the fall time is 0, 0. All right. Similarly, for node D, it's given to us till E. So arrival time is 0, 0. For node E, arrival time is again 0, 0. And for node F, arrival time is 0 cross 0. So all this was already written. We have just written it for a particular individual nodes. So arrival time at A, B, C, D, E, and F is 0, 0. All right. Rise time and fall time. Now let us go to node G. Okay. So let us go to node G. So let me recreate the node G. This is node G. The delay associated with this NAND gate is 4 by 3. And here arrival time is 0, 0. Here it is 0, 0. And this is A and B. All right. This is node G. This is not 9. This is node G. and we have to find the arrival time at node G. So let us write down node G. All right. So let us calculate the arrival time at node G. So for that we require the input fall arrival time and input rise arrival time. So we'll write down over here input fall arrival time is 0, input rise arrival time is 0. Here it is. This is rise, this is fall, this is rise, this is fall. So both are 0 0. So no need to take the maximum or minimum value. So here the rise delay is associated with the NAND gate is 4, and the fall delay it's 3. So the arrival time at node G will be given by, so arrival time at G will be given by output arrival time at node G. It's given by what value now? It's output fall arrival time, output rise arrival time first will be maximum of input fall arrival time plus T rise. So this is 0 plus T rise is 4, and this will be divided by input rise arrival time. I mean first above will be rise and below will be fall. So this will be um, output fall arrival time will be maximum of input fall arrival time plus T fall. So this will be 0 plus 3. So the arrival time at node G is 4 cross 3. Here it is. Let me highlight it over here like this. So this is my arrival time for node G. Now next let us calculate the arrival time for node H. First of all, let me recreate the node H for you all. So this is my node H. So it is a C and D as an input and it's a NOR gate. So here we have 3 by 5 is the gate delay, the rise and the fall delay with respect to this NOR gate. This is H, and the input arrival time and fall time at both the places is 0 0. Alright, so let us calculate the arrival time at node H. How much? So for that, let us write down the input fall arrival time is 0 and input rise arrival time it's also 0. Since it's a inverting gate, um, the the rise time associated rise delay will be 3 and the fall delay will be 5. This is the rise delay and this is the fall delay. All right. So what will be the arrival time over here? How will you calculate arrival time at node H? So it will be given by the output rise arrival time divided by input fall arrival time. So output rise arrival time is maximum of input fall arrival time plus T rise. So it is 0 plus 3, and output fall arrival time is maximum of input rise arrival time plus T fall. So it will be 0 plus 5. So this will be 3 by 5. So that's the value of out arrival time at node H. Next we calculate for node I. So let us recreate node I first. So node I is output of a AND gate, input is ENF. So node it is I, input is ENF, and here the rise and the fall arrival time is this 0 0, and the rise and the fall delay is 2 and 3 respectively. Now let us find out the arrival time at node I. So for that let us write down the input fall arrival time. Here it is 0. This is rise, this is fall. Both are same, so that's why we don't consider the maximum. So input rise arrival time is 0. The rise delay is, this is the rise delay, this is the fall delay. So rise delay is 2 and the fall delay is 3. Alright. Now let us calculate the arrival time at node I. So output rise arrival time will be maximum of input fall arrival time plus t rise. So it will be 0 plus 2, and here it will be input fall arrival time will be maximum of output fall arrival time will be maximum of input fall arrival time plus t fall. So it will be 0 plus 3. So that will be 2 by 3. So that's the arrival time at node I. Now let us check the arrival time at node J. So here we have to be careful. At node J, okay, so it is G and H as the inputs, and J is the output, and it's a OR gate. Okay, so here it is node J. So over here we have a OR gate with the rise and the fall delay as 5 and 4, and J is the output node. Input node is G and H. So for G and H we have already calculated the arrival time. So how much it is? For G the arrival time is 4 by 3, and 4 and 3, and H is 3 and 5. So we have to write it over here. um, 4 3, and this is 3 and 5. So these are basically the rise and the fall delay. So this is rise, this is fall, this is rise, this is fall. So here we have to consider the maximum values. All right, so let us write down input fall arrival time, it's 3. This is fall arrival time is 3 and 5, and input rise arrival time is 4 comma 3, and here the rise delay is 5, fall delay is 4. So what will be the arrival time at node J? It will be maximum of, it will be output fall arrival time will be input rise arrival time, that will be maximum of 4 comma 3 plus t rise, and output fall arrival time will be maximum of input rise arrival time, input fall arrival time divided by, I mean it will be 3 comma 5 plus t rise, I mean t fall actually, plus 4. So this will be actually output fall arrival time will be maximum of input rise arrival time plus t rise, and output rise arrival time will be maximum of input fall arrival time plus t fall. Here it is. So maximum of 3, this will be 4 plus 5, and this will be 5 plus 4. This will be 9 by 9. So this is the arrival time at node J. Alright. Now let us go back over here. Now similarly we have to calculate for K. For K is a NAND gate with input H and I and K as the output. So this is node K. Alright. So what is there in node K? We have a NAND gate with inputs as, oh sorry, in the earlier case it was a non-inverting gate. Alright, so it is output rise arrival time, it will be input maximum of input rise arrival time plus t rise, here it is, and output fall arrival time will be in maximum of input fall arrival time plus t fall. So that was the formula. It was a non-inverting gate, so my bad. This also was a non-inverting gate, so similar to this. So output fall arrival time divided by input fall arrival time. So that accordingly we will have to write it down. I guess we have written that earlier. Is this correct? Node I. Yeah, 2 by 3. Yeah, correct. Rise and fall. Correct. This is an inverting gate and its inputs are, this is K, inputs are H and I. So for H and I, what are the arrival time? This is H, it is 3 and 5, and for I it is 2 and 3. So for I it is 2 and 3, and here it is 3 and 5. So these are nothing but the rise and fall time. Rise, fall. So we need to calculate the arrival time at node K. So arrival time at node K, first of all we need to calculate the input fall arrival time. It's, there are two values, so max of fall arrival time 5 and 3, and next will be input rise arrival time will be maximum of 3 comma 2. The rise delay is 4 and the fall delay is 3. So how will you calculate the arrival time at node K? Output fall arrival time will be equal to maximum of input rise arrival time plus T rise. So it will be maximum of output rise arrival time will be uh, input maximum of input fall arrival time plus T rise. So 5 maximum of 5 and 3 plus 4, and output fall arrival time will be maximum of input rise arrival time maximum of 3 comma 2 plus T fall. So it will be 5 plus 4 upon 3 plus 3. That will be 9 by 6. So this is the arrival time at node K. Now let us see next. At node L, we have to calculate the arrival time at node L. Alright, so let's do that. So inputs, it's a NOR gate with inputs as J and K. Yeah, so now it is node L. So here we have a NOR gate. This is node L and the inputs are J and K. Let us find out the arrival time at J and K. For J it is 9 by 9 and for K it is 9 by 6. So 9 by 9, 9 by 6. Alright. So here these are also rise time, fall time. This is rise, this is fall. Okay. So we need to find the arrival time at node L. So for that we'll calculate input fall arrival time is maximum of 9 comma 6. Input rise arrival time is max of 9 comma 9. It actually is 9 only, and here the delay associated with this will be 3 by 5. So T rise it's 3, T fall it's 5. So now let's calculate the arrival time. So it's a inverting gate, so output rise arrival time will be maximum of input rise arrival time, which is max of 9 comma 6 plus T rise, this is 3, and output fall arrival time will be maximum of input rise arrival time, that is max of 9 comma 9 plus T fall. So this will be 9 plus 3, this will be 9 plus 5. So arrival time at node L will be 12 by 14. Okay, I think one more node is remaining, the output node, which is node M. For node M the input is L. Alright, so let us calculate the arrival time at node M. It's actually a buffer. Output is M and input is L. Here the rise and fall time, the rise and fall delay is 1 and 2 respectively. And here L, at L we have calculated the arrival time. It's 12 by 14. So here also we'll write 12 by 14. So this is the rise time and this is the fall time. So we need to calculate the arrival time at node M. How will you do that? So here it is: input fall arrival time. Fall arrival time is 14. Input rise arrival time is 12. Your T rise delay is 1. Fall delay is 2. And now we'll find the arrival time. It's a non-inverting buffer, so output rise arrival time will be input rise arrival time plus T rise. So it will be 12 plus 1 divided by output fall arrival time will be input fall arrival time plus T fall. So it will be 14 plus 2. That will be 13 by 16. So with this, we have calculated the arrival time for all the gates over here. Combinational gates which we have given. We have found out the arrival time at every gate. Alright. Now we need to calculate the return time. So for the arrival time, we have gone from node A. These are the primary inputs from node A, B, C, D, E, F to G, H, I, J, W, L, and then reach to M. Now for return time, we'll go reverse. We'll go start from M, then we'll go to L, then J, K, then G, H, I, then A, B, C, D, E, F. Got it? We'll go reverse from output to the primary inputs. So let's start with node M. We are finding the return time. So node M actually, the return time is given to us. And we calculate the slack also. So return time at node M is given as 16 by 13. So basically this is the return, the rise and the fall time. Okay. So how do you calculate the slack? So slack at node M will be return time minus arrival time. So therefore slack will be return time of rise, arrival at rise, return time for fall minus arrival time for fall. Let us calculate the slack. How much it is rise time? Rise is 16, return time is 16 minus arrival time over here is, this is rise, this is fall. So this is 13 minus return time of fall will be 13 and here it is 16 minus 16. So it is 3 by minus 3. Please don't divide it. It's not a division. 3 by minus 3 will be minus 1, but it's wrong. It's a rise and a fall. Alright. Is this clear? Alright. Now we have found out for node M return time and the slack also. Okay. So let us put that back over here in the main diagram. So we have calculated the arrival time over here. So arrival time was 13 by 16. Return time was 16 by 13 and slack is uh, 3 by minus 3. So for node M we have calculated everything. Now we turn our attention to node L. Okay. So since we are going back, node L is coming from node M. Let us keep an open mind. So for this we have to calculate the, for node L we have to calculate the output rise return time. So we will evaluate output fall return time will be 13 and here output rise return time, it's 16. From where do we got this? We got this information from the given R. See, for M, return time is given as how much? For M, return time for M is 16 by 13. So this is return, this is fall. So from here we are getting these values. Okay, return time of the earlier node. I hope it is clear. All right. And here the fall delay we have to calculate from the previous gate. So for the previous gate it is 1 by 2. So fall is 2 and rise is 1. I hope it is clear. And since it is non-inverting gate, we have to keep in mind. So what will be the return time? So return time at node L will be output rise return time minus T rise upon output fall return time minus T fall. So what is output rise return time? 16 minus 1 upon this is 13 minus 2. So that will be 15 upon 11. So that's the return time for node L. I hope it is clear. Then we have to calculate the slack. To slack at node L will be return time for the rise denominator में and numerator में. Numerator it will be return time for the rise and denominator will be return time for the fall. So it will be this will be rise fall and this will be rise fall. So it will be 15 minus 12 upon 11 minus 14. So it will be 3 by minus 3 again. So slack came out to be 3 by minus 3. Okay. So let us fill in this information at node L in this diagram. At node L. Here it is. So arrival time at node L is 12 by 14. Return time is 15 by 11 and slack remains at 3 and minus 3. Now we'll move our attention to node J and K now. Let us go to node K. Yeah, this is my node K. So remember node K was the output was given to the node L. Okay, this was given to as one of the inputs to node L. Okay, so 3 by 5 we have to consider this delay 3 by 5. So now let's calculate the output rise return time. Output rise return time. How much it is? So what's the rise time for this L node L? 15 by 11. So we'll write down rise time for node L is 15 by 11. So output rise arrival time will be 15 and output fall return time will be 11. This is rise and this is fall. And the rise delay associated with the output gate is this is 3 and fall is 5. Now we have to find the return time. So return time at node K will be output fall return time minus T fall divided by output rise return time minus T rise. So that comes out to be 11 minus 5 11 minus 5 upon 15 minus 3. So that comes out to be 6 by 12. So that's the return time. This is rise, this is fall. Okay, now we calculate the slack, and slack we know it's return time minus arrival time, so it will be 6 minus 9 upon 12 minus 6. Here it is. 6 minus 9 upon 12 minus 6. So this will be minus 3 by 6. Okay, so node K is complete. Let us fill that information over here. So at node K, arrival time is 9 by 6. Return time is 6 by 12. And slack is minus 3 by 6. Alright, now we turn our attention to node J. For node J, the output is L. It's a NOR gate with output L. So its return time will be useful over here. So let's, and this delay will be useful. So node J, it's connected to node J. Where it is connected to? It's connected to a NOR gate. And remember, it is a non-inverting gate. Okay. So here it is 9 by 3. And what is the return time of L, node L? It's 15 by 11. So we have to consider that. Okay. For the output rise return time and output rise output fall return time. So let's calculate that. Output fall return time, you have to consider this. This is rise and this is fall. It is 11, and T fall delay we associated with this gate. It is 5. And then output rise return time will be 15 over here, and T rise over here will be 3. Here it is. Then how will you find out the return time at node J? It will be, it's a non-inverting gate. It will be output rise return time minus T rise divided by output fall return time minus T fall. So it is 15 minus 3 upon 11 minus 5. So yeah, so how much it is? It's actually reverse. For non-inverting gate, this is an inverting gate, so it will be fall. So this is output fall arrival time. This is rise. Because we are looking at the earlier gate. Okay. And this is rise. So this will be reverse. We need to check what is the condition for the earlier gate. So it is output fall is 11 minus 5 upon 15 minus 3. So this will be 6 by 12. Alright. So this is the return time at node J. If you notice one thing, return time at node K is 6 by 12 and node J is also 6 by 12. Why is that? Because they are going to the same, they are going as input to the same gate. So the slack also will be, let's calculate the slack for this. I think slack also, the slack might be slightly different because arrival time is different. Yeah, let's calculate it. Slack at node J will be return time minus arrival time. So this is R, this is F, R, F. So it will be 6 minus 9 upon 12 minus 9. So it will be minus 3 upon 3. So it's different. So let us write this information: arrival time, return time, and slack in the main diagram. Yeah. So arrival time at node J, it's 9 by 9. Return time it's 6 by 11, and slack is minus 3 by 3. All right. Now let us go and calculate for next will be node G. Sorry, node I. First we'll go to node I. For node I, output is K. Okay, remember that this is a non-inverting gate and NAND gate. All right, so let's check it out for node I. So for node I, it's connected to one of the NAND gates whose rise and fall time is 4 cross 3. So this is node K. All right, where the return time of node K is 6 by 12. Let us find out that K, node K, return time is 6 by 12. Yeah, it is correct. And the delay associated is 4 by 3. So we have to, for the return time, we have to check the previous gate where it is connected to. So now we'll find the output for return time. We are talking about the return time. It's 12. This is R, this is F. So this is 12. Output rise, return time is 6. What is the rise delay over here? 4. Fall delay, it's 3. Then now we have to calculate the return time at node I. So it is given by, it will be output rise return time minus T rise upon output fall return time minus T fall. Okay, so it will be 6 minus, this is 4 by K. For K is 4 by 3. Okay, for yeah, correct. This is correct. So how will you calculate? Sorry, it will be, so it's an inverting gate. It will be output fall return time minus T fall divided by output rise return time minus T rise. So it will be 12 minus 3 upon 6 minus 4. It will be 9 by 2. This is the return time at node I. Now let's calculate the slack. Let me write it properly. 9 by 2. Let us calculate the slack at node I. Return time minus arrival time. So this is RF, RF. So it is 9 minus 2 divided by 2 minus 3. So it is 7 by minus 1. So this is the arrival time, return time, and the slack for node I. Let us fill that information over here. So the arrival time at node I will be 2 by 3. Return time is for node I 9 by 2, and the slack is 7 by minus 1. Okay, it's not a division again and again I'm repeating. Now let's calculate for similarly for G first. Okay. So basically G, it's going to J. So it is going to J as one of the inputs. Here the delay is 5 by 4. Remember it's a non-inverting gate, and here it is J. So what is arrival time at J? Sorry, return time we calculate. Return time will be over here. So for J it is 6 by 12. It is 6 by 12. So let's calculate um, output fall return time. This is rise, this is fall. So this will be 12 output rise return time. This will be 6. Then what will be the rise delay? T rise is 5, T fall it's 4. So what will be the return time at node G? It will be output rise return time minus T rise upon output fall return time minus T fall, because it is an inverting non-inverting gate. So it will be 6 minus 5 upon 12 minus 4. It will be 1 by 8. That will be the return time at node G. And similarly, we'll calculate the slack now. Slack at node G will be return time minus arrival time. So this is R, this is F, this is R, this is F. So it will be 1 minus 4 upon 3 minus 8. So, oh, sorry, 8 minus 3. So it will be minus 3 by 5. So that is the slack at node G. Let us fill this information over here at node G. Okay, so this is arrival time. At node G it's 4 by 3. Return time it's 1 by 8. And slack is minus 3 by 5. Okay, now at node H. Node H is going as two inputs over here and here. So let us calculate it. At node H, actually node H is a special condition. Let us see how. So here it is 3 by 5. It is basically going as two places as inputs. One over here and one over here. This is K, this is J, this is H. Okay, so here actually this is 5 cross 4. This will be 4 cross 3. So what is the return time from uh, H to J? You have calculated, right? It's 1 by 8. Here it is, H to G. Return time at G, because your under input is G, right? Your return time is 1 by 8. And your other input is it's I. For return time for I will be 9 by 2. Okay. All right. So we know the return time of both the cases. So return time for H to K, it's also 9 by 2 because they are the same inputs. These are both the same inputs. This is G, this is I. So now the actual return time for this will be the minimum of 1 and 9, the rise time, and fall time 8 and 2, because it's going at two places, right? Again I write for G and I. So this is G. Here the return time was 1 by 8, and here the return time is 9 by 2. This was input I. So this both the inputs will have the same return time. So this will be now minimum of this will be 1 by 2. So that's the return time for node H. We will calculate the slack for it. I hope it is clear. Return time minus arrival time. So arrival time is this. This is 3. This is R and F. This is R and F. So it's return time minus arrival time. So it will be 1 minus 3 upon 2 minus 5. So it will be minus 2 upon minus 3. So that's the slack, return time and arrival time at node H. So majority of the work is over, only 10% is remaining. Please be patient. So this is arrival time at node H. It's 3 by 5. Return time H, just now we have calculated 1 by 2. And slack is minus 2 by minus 3. Okay, now we have to calculate for A, B, C, D, E, F. Now, whenever their arrival time, all the arrival time are 0, 0. So directly we can write down arrival time is 0, 0 for both the cases. For this case together, we'll calculate arrival time is 0, 0. Arrival time is 0, 0. Okay, so whenever the arrival time is 0, 0, whatever is the return time. Now let we will calculate that, no problem at all. So now it will be easier to calculate this. Let us go to the earlier case for node A and B together. We'll calculate it. So here the return time will be we have to consider 1 and 8. So we'll calculate for A and B together because they are in the same A and B together because they are the same inputs. Here the arrival time is 0, 0. So they are connected to G. So G, what is the return time? 1 and 8. Okay, so let us write down output fall return time. It's 8 because it's connected to over here. It is fall. This is rise. So output rise return time it's 1. Whereas T fall of the previous gate, how much? T fall over here. It's 3. This gate only. 3 and 4. Fall time it's 3 and rise is 4. So what is the return time for this? Return time will be output fall return time minus T fall upon output rise return time minus T rise. So it will be 8 minus 3 upon 1 minus 4. So that will be 5 by minus 3. That will be the return time. Actually, we'll calculate the slack also. Slack will be very simple. Return time minus arrival time. So return it will be return since arrival time is 0, 0. It will be same as return time. Slack will be same as return time. So let us write this down over here. Here the return time for A and B it's 5 by minus 3 and here slack is also 5 by minus 3. Slack and return time will be same for C and D also, for E and F also. Now let's calculate for C and D. So we will calculate this for D and C together. Okay, so for C and D, what is the return time over here of the output? This is 1 and 2. So output rise return time is 1, output fall return time is 2. So let us write it down. Output fall return time H2, output rise return time it's 1. And what about the T rise and T fall? 3 and 5. T fall is 5, T rise is 3. What will be the return time? Output fall return time minus T fall upon output rise return time minus T rise. So 2 minus 5 divided by 1 minus 3. So it will be minus 3 upon minus 2. Similarly, slack will be same. Minus 3 upon minus 2 since arrival time is 0. So let us put in this information over here. So here the return time is minus 3 by minus 2 and slack will be, let me write it properly, slack also will be minus 3 by minus 2. Alright, now for E and F the output return time will be 9 and Uh, so we are calculating for these two now, node E and F, because they are the same inputs. So the arrival time is 0, 0. The output fall, you have to look for the previous gate. So this is the previous gate. Fall return time will be 2. Output, look over here. Yeah. Output rise return time is 9. What about T rise and fall? Here it is 2 and 3. Alright. So now let us calculate the return time over here. So return time will be output rise return time minus, since it's a non-inverting gate, others were inverting gates. So fall was coming first and below rise. Here it is rise first. So output rise return time minus T rise, that will be 9 minus 2 upon 2 minus 3. Output fall return time minus T fall, that will be 7 by minus 1, and same will be the slack, 7 by minus 1. Alright, I hope it is clear. Let us put in this information over here. The return time is 7 by minus 1 and the slack is also 7 by minus 1. Okay, so we have filled the complete information about, we have found out the return time, arrival time and the slack for this combinational logic. In this manner we can simplify, we can calculate the arrival time, return time for any combinational logic. Yeah, so that's it for this lecture. Thank you all for joining.